determining exact locations, we usually use coordinates. Now, traveling boats usually determine their exact location through the use of coordinates. By means of coordinates, other people can easily locate them. In the study of trigonometry, we always make use of coordinates. Look at this unit circle. Here, point P is on the unit circle with coordinates denoted by x, y. Let us start looking at the points on the axis. Here we have points A, B, C, and D. What do you think is the abscissa or the x-coordinates of point A, since the radius of the circle is 1 unit?
It must be 1 because point A has a distance from the center equal to the radius since A is on the circle.
Great idea, Elizabeth. So what are the coordinates of point A?
It must be 1, 0. Since the point is on the x-axis, the ordinate or the y-coordinate must be 0.
Very good. Would anybody like to find the coordinates of B, C, and D? Alright, Jan, Paolo, and Louie, go to the board and show your answer. If you notice, it is easier to identify the coordinates of the points on the coordinate axis. However, how can we find the coordinates of the rest of the points on the circle?
I think we need to know one of the coordinates, either the x-coordinate or the y-coordinate, in order to determine the other.
How can you do it?
Take point B for example. The x-coordinate cannot be easily solved, but the y-coordinate is equal to 1/2.
Aha! You're right. But how can we find the other?
Well, I'm not sure.
Notice that if we drop a line from point B perpendicular to the x-axis and call the point of perpendicularity as P, and draw the radius from the center to point B, a right triangle is formed. This is triangle OPB. Since OB is equal to 1 unit and BP is equal to 1/2 or 0.5.
Now I know. We will just use the Pythagorean theorem every time we come across a right triangle whose two sides are given and the remaining side is not known.
Great idea, Louie. However, if we will not use the Pythagorean theorem, there is an alternative, which is actually easier. This was derived from the Pythagorean theorem.
Aha! I think I have the idea. Besides, Jan was assuming that for point B, y is equal to 0.5. What if we didn't draw the unit circle on graphing paper? It would be difficult to assume any value.
So, what's your point, Paolo?
The only given value here is the radius, which is equal to 1.
But isn't it obvious that y is equal to 0.5?
I think we have a very interesting discussion here. To resolve the issue, let us take a look at this. If you notice, we were assuming that the ordinate or the abscissa of a given point is 0.5. Because if we draw a line segment passing through the point and parallel to either of the axes, it will cross at y equals 0.5 or at x equals 0.5. And since it is given that r is equal to 1, we can easily find the other side of the right triangle formed by making use of the Pythagorean theorem. Right? What if we do not assume the value of either x or y coordinate?
Is it possible? The Pythagorean theorem can only be applied if two of the sides of a given triangle are known.
You were right. However, I want you to think of another way. This would be another challenge. Recall everything that you learned about right triangles.
Can we make use of an angle instead? I mean, a special angle. The one that we have just discussed can be done more easily if we make use of special angles.
Can you explain that further, Elizabeth?
We know that the degree measure of any circle is 360 degrees. So we say that if 360 degrees is divided into 12 equal parts, each central angle must be equal to 30 degrees. If we are able to form a right triangle, it must be a 30-60-90 special triangle.
Aha! We can make use of that theorem involving special right triangles, right?
Definitely.
How?
Do you still remember the theorem on the relationships of the sides of a 30-60-90 special triangle?
I think so. Let me try. The shorter leg or the leg opposite the 30-degree angle is half of the hypotenuse. And if I remember right, the longer leg or the side opposite the 60-degree angle is half of the hypotenuse times square root of 3.
You're right, Paolo. Lisbeth, will you please show your explanation on the board?
Sure, ma'am. Look at this. OB is equal to 1 unit, which is the radius of the unit circle, and this is the hypotenuse of triangle OPB. The shorter leg is half the hypotenuse, so it must be 0.5, which is the ordinate of point B, and side OP, which is the x-coordinate, is equal to 0.5 times square root of 3, or equivalent to 0.87.
Great! Would anyone like to verify the coordinates of point C using this method?
Let me do it. The leg opposite the 30-degree angle is 1/2 of the hypotenuse, so it must be 1/2. The longer leg of the right triangle is opposite the 60-degree angle, and it must be 1/2 times square root of 3, which is 0.87. Therefore, point C has 0.5, 0.87 as its coordinates.
That's correct, Paolo. So, what if a point is on the second, third, or fourth quadrant? What do we consider in getting the coordinates?
We will consider whether the abscissa or the ordinate is positive or negative in a given quadrant.
How? Yes, Jan?
If the point is in the first quadrant, both its x and y coordinates are positive. In the second quadrant, the x-coordinate is negative and the y-coordinate is positive. In quadrant 3, both coordinates are negative. And in quadrant 4, the x-coordinate is positive while the y-coordinate is negative.
Aha!
That is correct. So you were able to identify another method for finding the coordinates of a point on the unit circle. This time, let us complete the table on the board.
Another challenge?
That would be nice.